Hello, Professor Sargent here with you again. Now it's time to talk about quadratic functions, graphing the parabolas that go along with them, and an application question. So here we go. On this first one, we have two options, although you should be careful to know the expectations of your teacher. Our first option to look at f of x equals x squared minus 2x plus 3, graphing it using transformations, our first option is to complete the square. And to do that, just to make things a little less cumbersome in writing, I'm going to replace f of x with y. I isolate the x terms. Notice that this is a function, so y is also a variable involved in this. And we don't know specific numbers for y, so do not try to do anything different than this. Side work for completing the square is to take half of what's in front of x to the first, since we do have a 1x squared. If we don't, we'd have something else to do first. But we do have a 1x squared, so half of what's in front of x to the first is negative 1. When you square that, you get positive 1. So add that to both sides. Don't backtrack. Combine the like terms here and factor this. I know that x squared minus 2x plus 1 is equal to the quantity x minus 1, all of that squared, because of the first step of side work. And then isolate y again. You cannot combine the 2 with the negative 1 because the minus 1 is inside of something that is being squared. So what good does that do us? And before I get to that, another option would have been to take the function as we started with. Oh, by the way, I'm going to replace y with f of x again. If I use the formula x equals negative b over 2a, that is going to give us the x-coordinate of the vertex. So I'm looking back at the original here. Those two negatives cancel out. That reduces to 1. And notice how we have that 1 inside, although there's subtraction. By completing the square, I put the quadratic function in this form. Having started with this form, and the a is the same, the coefficient of x squared, in this case 1, although it's not written, one time something doesn't change it, that is the same. H is the x-coordinate of the vertex, and k is its y-coordinate. All I have to do in either version is plug in the 1. Suppose that you started with this. If you hadn't completed the square, then f of 1, we would have 1 minus 2 plus 3. So that's negative 1 plus 3 equals 2. That is the same value that we have for k from completing the square. What good this has done us is tell us that there is a shift right 1. Since that's just a 1 in front, there is no reflection over the x-axis. There's no vertical stretch or compression. But we have a plus 2 after the squaring. which gives us the shape of the parabola. That's telling us that this goes up 2. So those two transformations could be applied to y equals x squared. If you square those four numbers, here's what we have. However, think of these not as the x's, but as x minus 1. And this is x minus 1 squared. Then on the one hand, to know what the x coordinates to plot are, shift these right 1 unit. So 1, 2, 3, and 4. If you notice, you plug in 1 for x into x minus 1, you do get the 0. You plug in 2 into x minus 1, 2 minus 1 is 1, and so on. Finally, our y coordinate that we're going to plot is after we shift up these y coordinates here by 2. So 2, 3, 6, and 11. I'm going to plot those 4 points in just a moment and then get our complete graph of the parabola following that. Remember what we're plotting. Looking at the first and last column, 1, 2, 2, 3, 3, 6, and 4, 11. So let's see those 4 points plotted. Here we go with 1, 2, 2, 3, 3, 6, and 4, 11. The vertex has an x coordinate of 1, and the equation x equals 1 gives us the axis of symmetry. So I could go, since this point here, 2, 3 is 1 unit left, 1 unit right of the axis of symmetry. I could go 1 unit left and have the same y coordinate. So 0, 3. Coincidentally, a y-intercept. Similarly, 3, 6. That is 2 units to the right of the axis of symmetry. So we'll go 2 units to the left and plot -1, 6. Do the same kind of thing for the point 4, 11 to wind up plotting the point -2, 11. And if I put in the equation of, our quadratic function, the equation of the parabola, the way it was originally written, it does connect those 7 points. I want you to notice that there are no x-intercepts. So as a quick side note, we can see that that should have been true from the beginning. You may be familiar with the discriminant, b squared minus 4ac. That is the part that's under the square root in the quadratic formula. If we had set y equal to 0 back here and tried to find the x coordinates, that would make y equal 0 so that we would have x-intercepts. Then as you would try to solve for that using the quadratic formula, let's see, we've got b is -2, a is 1, and c is 3. So when we put those into the discriminant, we get 4 minus 12, which is a -8. That's less than 0. So trying to solve the equation of x squared minus 2x plus 3 equals 0 has no solutions. No real solutions, that is. So there are no x-intercepts.